Welcome to Spring Lib.
We're asked to find the minimum vertical distance between the parabolas y equals x squared plus 1 and y equals x minus x squared. Well, to do this, first notice the vertical distance between these two, d of x. This is the absolute value of x squared plus 1 minus x squared, which is the absolute value of 2x squared minus x plus 1. Now we know that the distance d is minimized when it's square. D squared, which I'll call f, is minimized as well. Now the function f of x, this is d squared of x, which is 2x squared minus x plus 1 squared. All right. Now, in order to find the minimum value of f, I'm going to take the derivative of f. So we have f prime of x is, by the chain rule, 2 times 2x squared minus x plus 1 times 4x minus 1, which is equal to 0. So the critical values satisfy 2x squared minus x plus 1 equals 0, or 4x minus 1 equals 0. Now the discriminant of this quadratic equation, delta, this is b squared, which is 1 minus 4 times a, which is 2 times c. So this is 1 minus 8, which is negative 7, which is less than 0. So this first equation has no real solutions. The second equation has the real solution, x equals 1/4. Now, at this point, we're only considering, we haven't restrained our function to an interval. However, notice that our function f of x is in fact approaches positive infinity as x approaches plus or minus infinity. Therefore, it follows that f has an absolute minimum on its domain, and its absolute minimum must occur at one of the critical values. So it follows that f has an absolute minimum at x equals 1/4, and therefore the minimum vertical distance is d of 1/4, which is the absolute value of 2 times 1/4 squared is 1/16 minus 1/4 plus 1. This is the same as 1/8 minus 1/4 plus 1. This is 1/8 minus 2/8 plus 8/8, which is 9 minus 2 is 7/8. Absolute value of 7/8, which is just 7/8. And this is our answer.